All right. I hope everyone can hear me fine. Thank you very much. So thanks for joining me today in this very private session here. So it actually makes it easier for me. I'm here today to talk to you about Icinga, which is a monitoring tool, open source. And yeah, my name is Blerim. I'm with Icinga since 2018. That's when we founded the company. Icinga, the tool, actually exists since 2009. We're based out in Germany, Nuremberg. That's in the southern part of Germany, and that's basically where all the beer comes from, that region. Icinga itself, if you have never heard of it, is a monitoring solution that detects the availability of your IT infrastructure components. It detects if your network devices are up and running, if your applications are responsible, if your databases are fast enough. So it's a very universal tool with a modular architecture. And I will get back to that later to introduce you to how it works internally. Icinga is an open source tool. Of course, I wouldn't be here otherwise if it wouldn't have been open source. And it has plenty of different integrations. So our philosophy is that we try to do what we can do best, and that's availability monitoring. For all the rest, we leave it to others, and we rather create integrations than reinvent the wheels. For example, for time series databases or graphing solutions. I think it's very scalable. I will get to that point later as well. And it has a very smart way of how you create the configuration to actually tell Icinga what you want to monitor and what way. I will be switching between a demo and some slides. I don't have too many slides on purpose, so bear with me if it takes a minute between switching modes. So to give you an idea about what Icinga actually is, no, that didn't work. Give me a sec. Change, extend here. No, that was wrong. I want to mirror. All right, here we go. So when you first log in into Icinga, what you get is a very simple view of a default dashboard that tells you exactly what is broken right now. And that's also the idea behind of Icinga. The idea is basically to have this systems of a couple of different colors that indicate what is currently going on. So from our experience, our users or the systems administrators using Icinga, what they actually like about it, that it's very clear and fast in telling you exactly what is right now broken. And it gives you those details in different dashboards. So what we are seeing here is a standard dashboard that pops up after the standard installation. And then as a systems administrator, you can start digging deeper. So I can see that the load is in a red state. Red means it's critical. So basically there are three different states. Something can be green, so you can ignore it. It's okay. Something can be yellow, so you can have a look into it, and something can be red. That's when something definitely is broken. If we check this out here, for example, what we are checking here is if the cron process is running. So a very basic metric. And Icinga tells us, okay, this is red because there's only one process with a command name cron, and perhaps we expected more or less with the thresholds that we configured. What we can see is that we have different contacts that would have been notified about the state of this. We have contact groups, and we have details about when this was executed the last time and when this check is going to be executed the next time. So some fundamental information about what is currently going on. So you can imagine this same behavior with lots of different things as well. So I'm using here in my demo load and disk and everything. But it could also be a query to your database. It could be the response time to your application server. It could be the state of your web server. It could be the network connectivity of your routers and switches. That's where we start. Additionally to that, Icinga allows you to also visualize if something has a dependency to something. So for example, if you have hypervisor or network devices that actually depend on each other. You will see that as well. Again, always with the idea to have a very clear view, so there's no noise around it. We try to always show the most relevant information in each view that we have here. And then we, of course, have different other views as well. So just to give you a summary, or to have different views where you can tile different cubes. So for example, you can tile it into and separate into show me the information about in which environment something is running. Let me see if I can make that bigger for you. And then you can move on and split it further and add another dimension and tell me, okay, in which location is this running? So there are different options to give you these very simple views. Icinga does that by executing plugins. So there are hundreds of thousands of different plugins out there. The majority of them are built by the community, so we are not plugin builders, except of Windows, because nobody else wants to build plugins for Windows. We're doing it on our own. But all the Linux stuff, all the application stuff out there is coming from the community. So Icinga actually uses those plugins to detect the state of something and return those information to Icinga. And that's the very basic part of what Icinga actually does. So it executes those plugins, it determines the state of something, and it tells you about it. In a nutshell. The more interesting part, for me at least, is how do we configure Icinga in a very dynamic way to actually tell it what it has to do. So how does Icinga know that it has to monitor SSH connectivity on each Linux server, for example? What we use is a concept of where we let the user describe their environment, and then based on those descriptions, express their monitoring rules. So it's a rule-based configuration. It's a custom DSL that lets you exactly express things like this. So you can tell Icinga monitor SSH on each Linux server. Or you could do something very similar to monitor Nginx on each web server, which is very simple. But this goes also further with more complicated stuff. You could tell Icinga to monitor MySQL on every database server, which is in production, but not located in Rally. So things like this are possible to tell Icinga how to behave in monitoring. And the same idea is applicable to notifications and alerts as well. So the rule-based engine will allow you to do things like alert John, but only during business hours, or the other way around, alert this person outside of business hours. How does this work? As mentioned before, we kind of use this concept of describing and expressing things. By describing, what we mean is that you add metadata to your objects. So you can imagine your servers, machines, or whatever you have in your IT infrastructure, and you add information to it, like this thing is located in Rally, this thing is in production use, and so on. So you tell Icinga in the first step what is going on. And the second step afterwards is you express what you want to do with that information. Now, that seems very easy, and it actually also is. So a basic configuration is in Icinga looks like this. So you have an object, which is in this case a host, and you have these what we call custom variables. Those custom variables can be basically anything. So in my demo here, I have two types of custom variables. I have strings and I have a Boolean. And I can later in my rule-based engine react on those custom variables and use them to make Icinga behave in a certain way. What is also possible here is that you not only are limited to strings and booleans, you could also have arrays and dictionaries. So you can also iterate over things. This comes in handy, for example, if you have a server with multiple virtual hosts. You could add those virtual hosts to a dictionary and tell Icinga, okay, this host is running these virtual hosts, this is on that port, and this is on that port. If you have multiple disks, a storage system with multiple information on it, you could even use it for different contexts. So basically, it's a multi-use purpose. You can use these metadata that you add to the objects for monitoring purposes to exactly tell Icinga, okay, do this if that is the case. And you can use the same information for alerts and notifications as well. The express part in a technical way, so we saw how in a human way how we would express it. In a technical way, in the configuration language, it's very similar. So what we have is what we call a apply rule, indicated by the apply term, and we want to apply a service called MySQL. Now the example was monitor MySQL on each database server, which is located in Raleigh, was my example. Now I have London here, but you get the point. So what we do here is now we tell Icinga, apply this service, so attach this service to each host that I'm adding. And if this terms apply, then attach this service to it. The result is that every time I add a new host object to it and the metadata is detected and it applies to my rules, I can have multiple of those rules, of course, and Icinga will verify each rule when I add new objects, and it will figure out, okay, in this case I have to add this and this and this service, and in that case it's those services. So this is the first type of automation that is built in. It gives you the chance to create a very dynamic configuration. You can change parameters on the fly and make it behave differently. The most important part why users actually like this is because it reduces human errors. So you can imagine that Icinga is used in very large environments. So there are different people working with the same tool. Not all of them have the same knowledge about the tool, and this makes it easier for the users to eliminate those human errors where someone had a typo somewhere, someone else joined the team and doesn't know how it works yet. By creating this rule set for your own, you can create basically your environment in a very safe way. By default, these configurations are created in plain configuration files. So we have two ways of configuring Icinga. The standard way is using configuration files, which works very well for users who know what they are doing. So experienced Linux admins are very used to that and like using it. It allows you to create Git-based workflows as well, so you can versionize the configuration files, you can deploy them to the server, you can track the changes and so on. It's a super nice feature for experienced Linux admins. However, on the other side, it's again prone to human errors because, as we know in the Linux world, one typo can destroy your whole configuration. And even though Icinga will verify the configuration, it's still a mess if you create a wrong config file. And from our experience, even though it enables you to have Git-based workflows, it's still challenging if you have a team of people working on those configuration files. Therefore, there's also another way to create those configurations in a very similar way, but in the web, directly in the web interface of Icinga. So we call that thing Icinga Director. It's optional, so users can use it, but they don't have to. It allows you to do the similar things what we just seen right now, but in the web interface. So very simple, I can add hosts to it. Those hosts can have some custom properties. These are our custom variables that we've seen before. So it's basically the same thing. However, what we can do here now is we can validate and create options for those custom variables. So for example, I can just have a yes or no here. So I cannot do anything wrong. I can have different options for, let's say, an example, operating systems. While when using configuration files, you will have to use the exact term that you created before. In this case, if you're doing it in the web interface, you can give different options to the user, which makes it easier for people working in a team to actually use the correct metadata, and also limit the amount of available metadata to your administrators. Same thing applies to the apply rules as well. So it's very similar to what we've seen in the config files. It looks similar. It does the same thing. So we apply this to create a HTTP check where the operating system is Linux, for example. So I have the same assign rules here. It looks a little bit different, but it does in the background, it does the very same thing. The more interesting part about the director is actually the automation thing. Before I come to that, I've talked about Git-based workflows before. So what we experienced is that people actually like to track the changes. So what we've built in is that similar to what you can do with configuration files in Git is you can have the very same thing in the web interface as well. So we can see exactly who made which change at what time. We can see the difference, what was before and afterwards. We can see who did the change. The changes will get collected here, and afterwards you kind of deploy it. Deploying means basically we take the changes and we push them through the API to the Icinga server, and then it verifies it one more time and reloads the config. Now with this tracking opportunity, what we can also do is if we have some unwanted configuration, since we have a versionized system here, I can roll back very easy to older configuration states. So if my colleague or someone else from the team created a configuration that was valid, but it was still wrong in some way, I can very easy roll back to an older version. This may come in handy if working with manually configuring stuff. Where it definitely comes in handy is when you automate things. And this is the other important part about Icinga. It comes with a mechanism where you can attach your own data sources to Icinga and use your own data to actually, for example, create this metadata I've been talking about. So we have this automation part with a rule-based engine. It works very well because I create those rules once and I reuse it all the time. Here and there I make adjustments, but that's like my foundation of everything. Pretty good automation already. The other part is about creating this metadata. In a small environment, it works very well. If you have admins who know their environment, they can do that very easily by hand. If you have a large environment, you can use existing data to import it into your Icinga environment. What do I mean by existing data? That could be built-in things that we have are, for example, a SQL server. It could be PostgreSQL or MySQL. So if you have a CMDB running somewhere based on one of these database types, you can just run queries. And I have a very simple one here for demonstration purposes. So my example here is a database with a table where I have hosts and some metadata about these hosts. Let's imagine this would be my CMDB. And what I can do is I can just run native SQL queries to it and select the information that I need in my monitoring system and import that information. So SQL is one option. You can also import files. You could even import Excel files. or YAML, JSON, whatever you have. You can use Active Directory to import contacts. You can use LDAP if you have that. There's a PuppetDB source. You can use Ansible. You can connect it to your AWS account. You can connect it to your Azure account. You can connect it to your vSphere center, for example. So the idea behind this is we have some very generalistic import sources like SQL, LDAP, and some special purpose import sources like vSphere, AWS, and so on. The result of my example here, which is very simple, it's a single table. I'm selecting information, and the result of this is that now I have this information available in my Icinga. So that's like the first step. What I'm doing here is I'm automating the part of creating metadata. And to do that, first of all, I need the data in my Icinga system. And that's what we've done here. The first step is we have the data imported. I selected what I need, and now I can move on. One additional part is there is something included called modifiers. And there are plenty of modifiers available. I'm not using any here. So let's see what we can do here. So I can import that data, but also on the go modify it by using regex, for example, by doing DNS lookups for something, by converting time zones to something different, or by what else do we have? By combining multiple columns into one single value. So there are plenty of options available to work with your data, to bring it to a state that you can actually use it in Icinga. So what I'm doing here is I'm basically mapping those information into Icinga configuration. I'm basically telling Icinga that the object name should be created out of the column host name. And the address, we take that from the address field, from the address column. And then I have some metadata in my table, like location and environment and SNMP community. From those information, I'm creating custom variables. And this is where it actually gets interesting, because I can use every information that I have to create custom variables out of it. And now we have these two different parts. On the one side, we have our rules where we tell Icinga how to behave. And on the other side, we have this information coming from our data source where we get the metadata from it. There's a really nice integration for Netbox as well, which is becoming very popular. So you can also attach Netbox, for example, which has information about your network devices. And you can use the same information in Icinga and import it and combine it with other information. You can have multiple data sources, so you can get your contacts from Active Directory, you can get your servers from Netbox, you can get all your other things from AWS and combine it into one single interface. Now, with that in mind, you can create jobs and automate that thing. Automation means basically you are periodically rerunning those tasks. So once a day or every 5 minutes or every 3 hours, import the data, synchronize it with existing configuration. And during these steps, you can also decide what should happen with existing data if it gets overruled. So you can merge the data with the existing one, you can delete the existing one and use the new one. So plenty of options are available here. Now, if we think back to the activity log, it becomes even more interesting here, because we don't have any customly created configurations anymore. We have configurations created automatically by importing information from somewhere else. And now we can easily track what is actually going on here. So in this case, it's way more important to have this activity log and also to have the options to roll back to a previous state of the configuration, because even though automation helps us a lot, it can also, in certain cases, if your data source is broken for some reason and you get wrong data, it may be a problem, but you can solve it very quickly by just deploying an older version of the configuration. And then you're good to go, and everything is finished here. What we do with Icinga is it is it consists of multiple components, which we combine together to a stack, basically. We do that on purpose to, on the one side, not create a monolithic application, but rather have small services dedicated for certain tasks. So there is a piece of software that does the monitoring part, that collects the data. There's a web interface. Those are the foundations. That's something you're going to need. And then you can extend Icinga with either plugins to monitor certain things, but you can extend Icinga also with modules. And since we have an open source code and we have open APIs, users out there can use those APIs and create custom things for their Icinga. And we use the same mechanisms to create official modules as well. So what we do is we have our custom libraries available on GitHub. We have our own framework, which we are using internally, and we give it away to everyone else for them to create modules as well. Modules can be basically anything. It can be something like the cube that we've seen before, which is just a different type of view. But it can also be something like reporting that we create. We use the data that we already have to create different things. In this case, SLA reporting, because Icinga already knows the state of things and keeps track of the history. We can easily create SLA reports. We can create business processes. So let me check if I have an example for a business process here. So let's see, public-facing website consists of, so it's, let's pick the tree view. So a business process basically combines the state of multiple things with logical functions and creates a summary state of something. So for example, you can have a website, icinga.com. For the website, it's important that you have at least 3 out of 5 web servers available and at least 1 out of 2 database servers. And that would be a business process. So the business process aims to create a top-level view, for example, for management, where they are interested only on the state of the top level of something, and the administrators can continue working with the server metrics that they are interested in. Recently, we've been adding a new module for Kubernetes monitoring as well. So what we've seen until now is what I like to call traditional monitoring in a positive way. It works very well with having hosts and services because it's like it works in that way. But when we started creating a monitoring solution for Kubernetes, it was very clear in the beginning that hosts and services do not work with a Kubernetes environment. So what we did here, we extended Icinga with a custom module. In that case, it's not just a plain visualization of something. It also comes with a custom collector and a custom database schema, because Kubernetes data is just different from what we had earlier. So theoretically, what you can even do is you can use the Kubernetes monitoring module even without the things that we've seen until now. But what we do is we aim to create the same very simple view. So what we do is we just don't visualize the Kubernetes data. We also try to create these green, yellow, red states to give the very simple view that users are used to when using Icinga into the Kubernetes world. And this can look like this. You basically pick your entry point where you want to start. For example, I want to have a look at the deployments. Again, like we know from earlier, you get the very simple states. We can see that something is green here, this Nginx deployment. It gives us all the details that Kubernetes already has. We are using here the same libraries, the same SDKs that Kubernetes is using. So this thing is written in Golang. We can see the conditions, the whole environment that is attached to this deployment. We can dig deeper and move on to this part. The slowliness comes from the Wi-Fi, I guess, or from my broken demo, could also be. Let's pick something different. Here we have a Kubernetes deployment gateway quota. So first of all, you see all the relations. You can go down to the container if it works. Let me try it out one more time. Okay, even though my demo seems to be broken, you get the idea what we try to achieve with Kubernetes monitoring. Another thing which is different here is in the traditional monitoring space, we periodically execute the plugins. We can set a very small check interval, like 10 seconds or something, but still it would be not sufficient for Kubernetes because these kind of environments change very fast. In the Kubernetes case, we switch it around. We don't do pull-based monitoring. We rather push the information from within your Kubernetes cluster to Icinga. We store it in our own schema and then visualize it and run alerts based on those information. So it's the other way around, but it should just demonstrate how modular Icinga is, because you can exactly pick what types of things you are monitoring. You can add more to it later and even create your own modules. We do have customers that do these kind of things. And we also have a community that is very active. You will find different modules on GitHub from different people who are using Icinga and just share the stuff they are building. For example, there's a Grafana integration that we have from the community that displays your Grafana graphs in the Icinga web interface. There is a netbox integration. There is a maps module where we can have a map and pins on that. So many different things available out there. The last thing I want to share with you is how this works in very large environments. So we've been creating Icinga with large IT infrastructure in mind, and that means that from the beginning we created a cluster mechanism which is built into Icinga. So there's no third-party software required to create clusters with Icinga. Even though a single Icinga node with Icinga server and the web interface and all on a single node is already capable of monitoring a couple of thousand of machines, depending on the hardware. At some point, you can imagine that some of our users are monitoring 30 to 40,000 servers across multiple data centers. They require a way of how they can distribute the load. With Icinga, you have the following options. There's one option to, first of all, create a high available setup. In that case, we will just add to the same, we call it zone, where we have the first node, an additional node. What it will do is it will connect. So the two nodes will connect to each other with an SSL encrypted connection. This is the default and cannot be turned off. Icinga comes with CLI tools to manage those certificates. And once connected to each other, those nodes will share configuration with each other. So you still have one single node where you create configuration, because the configuration will be synchronized to the other nodes automatically. In a high available mode, the load will still be distributed to two nodes. However, if one of those nodes fail, the other will detect it and just take over. Since they share results all the time with each other, we can have a seamless takeover at any time. Further, to actually distribute the load, so if you have too many monitoring checks running, you can use something what we call satellites. It's the very same concept like we had before with the master nodes on the top. It actually uses the exact same binary, but it behaves different because it has a different configuration. Again, it connects to the parent via SSL encrypted connection, and it receives the configuration from the top, so it knows what it has to do, which checks it has to run. You can imagine that this is used by users, for example, to monitor a dedicated section of the network or a dedicated location, or however users would like to segment their monitoring configuration. Again, on the satellite level, we also have the option to create high availability. So even if one of the satellites fails, it will just move on. If the connection between a satellite and its parent node is interrupted for some reason, the satellites will just continue doing their work because they already have the configuration, they already know what they have to do, they can just move on to do the monitoring stuff. Since the connection is interrupted, they will not be able to push upwards the results, but once the connection is up again, they will start to push the results towards the parent again, and you will have you will not miss any result here. Last of all, yeah, I talked about this already, so it's mostly interesting for larger environments. One more thing that is included here is that you can use the same binary that we had for the masters and the satellites. You can run it as an agent as well. It goes very easy on resources, so, and it also receives its configuration from the top. It knows what it has to do. It's failure safe if the network connection is interrupted. It's the same mechanism, just a different role depending on the configuration what it gets. In the end, you will have a Icinga environment that looks something like this, where you have the masters on top responsible for handling configuration management. You will have a single point of creating configuration. You will have automation process where you can import data. And you don't have to take care about how the configuration gets deployed to the agents and to the satellites, because Icinga takes care of that automatically. I've been talking about modularity already. One more thing I would like to mention. There are open APIs out there. We have libraries available for different parts of the software. There are official modules, and there is a very active community. We've been around since 2009, and the community has been growing. So yeah, thank you very much for joining me here today. I think we have a few more minutes left if you have any questions. We do have a booth here, so upstairs in front of the DevOps ballroom. You can find us if you would like to discuss more in detail your use case or something. We will be there. Thank you. Technically, you mean? So the front end is built on PHP. So currently we are exploring ways to use PHP application servers. Actually, those are coming up. Right now it's normal PHP. Yeah. The key differentiator. So the way how you extend Icinga with plugins is different. With Zabbix, you would have those kind of templates and things that you create. Icinga works different because you have those small pieces of plugins that you can easily create on your own. There are hundreds of thousands available. They can be programmed in basically any programming language. It doesn't matter if it's in Python, Perl, Go, whatever. It just matters that they return an exit code and a message, and that's it. The logic sits in your plugin. The automation process is different because we have the opportunity to connect those third-party databases. And in general, the idea of integrating stuff with Icinga. So people are using it to connect it to their ticketing system, to their Jira, to their vSphere, to their AWS. So we don't try to kind of build all these things on our own, but rather connect to different time series databases. You choose if you want to use Elasticsearch or InfluxDB or Graphite or OpenTSDB. It's up to you. And it's your choice if you would like to include our own Graphite module or use the community plugin by the community. So it's more modular and allows you more customization. All right. Thanks again and see you at our booth. Bye-bye.